On this part of math, we are going to talk about multiplicative inverse of a matrix and also determinant. And this one is just complement for the previous video that is related to matrices. So on the previous video, you understand how to add a matrix, how to multiply a matrix, and how to subtract a matrix, and you understand what is the order of a matrix. In this part, we can understand what is the multiplicative inverse of a matrix and also what is a determinant. Okay. First, we can understand what does it mean, multiplicative inverse. Then second, we can understand what is determinant of a matrix. Then the third point, we're gonna find the multiplicative inverse. And last step, we're gonna understand the determinant of matrices, and they are 3 times 3. And also we're gonna understand how can we use these determinants to find the area of a triangle. Okay. If I have 5, and I'm telling you, it's just this is a number 5. What is the multiplicative inverse of a number 5? Number 5, what is its multiplicative inverse? Its multiplicative inverse is the number that when I multiply it by 5, I get 1. So what is a number here that when I multiply it by 5, I get 1? Of course, it is 1 over 5. So this number now, it is called a multiplicative inverse of 5. If I tell you now 0.2, what is its multiplicative inverse? You're going to see it's 5, because now 0.2 times what gives me 1? It gives you what? Times 5. Okay, what about if this one here is negative? Negative 0.2 times what gives me 1? It equals what? Negative 5. So you multiply them, I get 1, 1. So that means this number now is a multiplicative inverse of this one. Easiest way to find just for numbers, you put 1 over the same number in a denominator. Get same thing for a matrix. So when I tell you now, I have a matrix. Okay, this is the matrix. Okay, 3, 2, 1, 2. This is a matrix that is a square matrix. When I multiply it by another matrix, I don't know what is this matrix. I'll get a matrix which is called a unit matrix. And a unit matrix, by the way, it has the same order here, which is 2 times 2, but the main diagonal is 1, 1, and here is what? 0. So that means now the question is, what is the matrix that I put it here? When I multiply this matrix by this matrix now, I find the result here. If you have a problem in multiplication of matrices, go back to the previous video to understand how to multiply matrices, then come back to this video. So now what will be this matrix? This matrix, we call it multiplicative inverse matrix of what? Of this one, of the main or the original matrix. Okay, how can we find it? This is one main part of this video, is how to find this one. Good. To find this one here, we need to understand what is determinant. Determinant here, just say make it here. If I have here 3, 1, 2, 4, and I tell you find the determinant. Determinant is not like a matrix. So a matrix is, as you see, its brackets is square bracket. But here determinant, as it is 2 vertical bars. 2 vertical bars, and the numbers are between them. When I tell you find the determinant of this determinant here, what are you gonna do? First step, go to multiply the main diagonal. This is the main diagonal. Multiply 3 times 4 is 12. Thank you. And now multiply the secondary diagonal, which is this one. 2 times 1 is 2. Now subtract main diagonal, which is 12, minus the secondary diagonal, which is 2. So in this case, you will find it what? You will find it 10. Is that clear? So we understand now how to find the determinant of a matrix like here when it is 4 times 4. Okay, if I tell you now, this is now a matrix, which is 1, 2, 3, 4. This is now a matrix. And I tell you now, find me its what? It's multiplicative inverse. And its multiplicative inverse, that means the matrix that I put it here, when I multiply them, I get the unit matrix, which is 1, 0, 0, 1. Okay, what will be this matrix here? Okay, to find the multiplicative inverse, you have to move into steps. First step, memorize that. Find the determinant. Find what? The determinant of the first one. Okay, how can I find the determinant? I write it like this: 3, 2, 1, 4, good. And I find its determinant how? We multiply this one here, which equals 12. Then we multiply this one, which equals 2, right? So 3 times 4, when you multiply them, I get 12. And here, when you multiply these ones, 1 times 2, I get what? 2. So that means 12 minus 2 equals what? 10. So now I found the first point to find the multiplicative inverse. My goal is to find the multiplicative inverse that is here. I put it here. Get first step to find the determinant. Okay, I found the determinant. What is the second step? Second step, which is the second step. This determinant, it has to be its inverse. So that means this is 10. You write it like 1 over 10. Get whatever you find the determinant, you write what its multiplicative inverse. This is 10. I'm gonna write it like 1 over what? 1 over 10. And now this 1 over 10, you need to multiply it as the third step and the last step. This 1 over 10, you need to multiply it by the main matrix. What is the main matrix? This is the main matrix. Okay, but what you need to do? Look, you need to switch the elements of the main diagonal. This is 3 and 4, switch them. So put the 4 here and put the 3 here. Just I switched them, but they still in the same diagonal. You see, they are still in the same diagonal. Look, just I change the 4 in the place of the 3 and the 3 in the same, in the place of, okay, of each other. Now, 1 and 2, which is this diagonal, you see it? This diagonal, what to do? It change its signs. Now it is 1 and 2 positive, so it changed their signs to be what? Negative. You see? Okay. I hope that is clear now, these steps, how to find the multiplicative inverse. Now what to do here? As we know, if we have a number outside, we need to multiply it by each element inside. So we multiply it by each element inside. 1 over 10 times 4, first step. Here, 1 over 10 times 4, it's going to be 4 over 10. 4 over 10 simplified by 2 by 2, it's going to be 2 over 5. Thank you. Then 1 over 10 times negative 1, it's going to be negative 1 over what? Over 10. Good. Now multiply 1 over 10 here times negative 2. It's going to be negative 2 over 10. Simplified, it's going to be negative 1 over 5. Negative 1 over what? Over 5. Same thing, 1 over 10 times 3, it's going to be what? 3 over 10. You see here now? This result now is the multiplicative inverse that it has to be put here. That it has to be here. So this is now the multiplicative inverse. This multiplicative now inverse, to make sure it's right, here this is 2 over 5. And here negative 1 over 10. Get. And here's negative 1 over 5. And here's 3 over 10. Okay, let's now multiply these ones. Okay, let's multiply to make sure if we multiply this matrix and this matrix, will we find this matrix, which is the unit matrix? We're going to see how we multiply. We know how to multiply the first row times the first column, right? Get 3 times 2 over 5. 3 times 2 over 5. It's going to be 6 over 5. Get 6 over 5. 6 over 5. And now 1 times negative 1 over 5, it's going to be negative 1 over 5. Good. If you subtract them here, you will get 5, same denominator. 6 minus 1 is 5. So 5 over 5 is 1. So that means this one is right. 1 is right. Good. Now you multiply this one here by this one here to get, when I get 0, 3 times negative 1 over 10, it's going to be negative 3 over 10. Negative 3 over 10, right? And 1 times 3 over 10, it's going to be plus 3 over 10. Add them, you will get 0. So as you see, this one is 0. Okay, just to make sure, here we multiply here 2 times 2 over 5. It's going to be what? 4 over 5. 4 over 5. Then, so 2 times, as you see, 2 times 2 over 5, it's going to be 4 over 5. Good. And here 4 times negative 1 over 5, it's going to be negative 4 over 5. So 4 over 5 and negative 4 over 5 will give you 0, which is here 0. Last thing here, I multiply this one by this one here. As we know, as we studied multiplication in the previous video. So 2 times negative is going to be negative 2 over 10. And here it's going to be negative 2 over 10. And here 4 times is going to be 12 over what? Over 10. If you add them now here, you will get, as you see, 10 over 10, which is what? Which is 1. So that means this answer is what? Is right. So you understand what is multiplicative inverse. So to find multiplicative inverse, just repeat what the step. First step, you need to find the determinant, and you understand how to find the determinant. This row, this diagonal times, and this diagonal times, and subtract them, you get 10. This is the first step. Second step, we said, this result that you find it, make it 1 over that number that you get here. So then 1 over 10. 1 over 10 multiplied by the original matrix, but after you switch the main diagonal elements and you change the signs of the secondary diagonal elements, then when you multiply, your result here will be the multiplicative inverse of that one. Good. My question now, do we have a matrix that it doesn't have multiplicative inverse? All of them, they have multiplicative inverse. We understand multiplicative of 5 is 1 over 5. Good. But what is multiplicative of 0? Is there any number I multiply it by a 0 and it gives me 1? No. So that means there is no multiplicative inverse for the 0 here. So in this case here, it works with the matrix. How? If I have here, this is 3, and this is 6 here, and this is 12, or this is I put it 9, and here is I put it 2. And I ask you now a question. Find the multiplicative inverse of this matrix. Okay, we know what are the steps. First step, we find the determinant. How can we find the determinant? Main diagonal, we multiply it. 3 times 6 is going to be 18. And so that means it's going to be 18 minus the secondary diagonal, which is what? 2 times 9, which is 18. So 18 minus 18 is 0. Good. So that means the determinant, which is the first step here, the determinant, it equals 0. Good. What is the second step? The second step, we said we put this one as 1 over that number, 1 over 0. Good. What is the third step? We multiply this 1 over 0 by this determinant, but after we what? We change the places of these diagonal numbers. So that means here is 6, it's going to be, and here's 3. And we change the signs of these ones, it's going to be negative 2 and negative 9. Okay, but now this is 1 over 0. Is it defined 1 over 0? No. So that means when we multiply it by anything, it will be undefined. So that means in this case, this matrix, it does not have a multiplicative inverse. And I hope now you understand how can we find multiplicative inverse in these 3 steps. Okay, good. We take another example. If I give you now 3x, and here I give you 6 and 4. And I tell you this matrix, it does not have multiplicative inverse. Could you tell me what is x? Okay, a matrix that does not have a multiplicative inverse is the matrix that its determinant is 0. How can I find the determinant? The determinant, you multiply, as you said, the main diagonal, 3 times x is 3x, minus the secondary diagonal, which is 4 times, here it's going to be what? Times 6 is going to be 24. And this one now, if this result, which is determinant, is 0, So that means this matrix does not have multiplicative inverse. So that means 3x minus 24, since they said it doesn't have, that means this one equals 0. Send this one here, so 3x equals what? 24. So that means x equals what? X equals 8. So if x equals 8, that means this matrix does not have multiplicative inverse. Okay, what about if I put you here 2? Same thing, but you're going to write here 2 times 3, right? Here it's going to be 6, right? So that means here it's going to be 6. Then you multiply here, it's going to be what? 4. So x will be 4. So you understand now what is the multiplicative inverse and how can we find the multiplicative inverse of a matrix that is usually a square matrix, and its order is 2 times 2. We understand now how to find the multiplicative inverse of a matrix that is 2 times 2. We find its determinant, and we put the 1 over that answer of the determinant. Then we multiply that number or that fraction by the change that is in the original matrix, where we change the signs of the secondary diagonal, and we change or we shift the places of the diagonal elements, the main diagonal elements. Good. We'll go now. So we finished the first important point, which is how to find the matrix and multiplicative inverse, and we understand when a matrix does not have multiplicative inverse. Second point, now we're going to understand what is determinant. What is determinant and how can we find the determinant? Okay, determinant, we said this one is a determinant. That is like 2 vertical bars. And if you have 3, 5, 2, 8, we know how to find the determinant. As we said, it's the first step in finding the multiplicative inverse. Just to multiply these ones, 3 times 8 is 24, and then this one is 10, so 24 minus 10 is 14, and that's the determinant. Okay, what about if I have a matrix that is 3 times 3, and I want to find its determinant? I want to find its determinant. How? For example, I have this matrix, or this determinant now, 3, 1, 2, 0, 1, negative 1, 2, 3, 1. Okay, this one now is a determinant, but find its value, find its determinant now. What will be as a result? Okay, if it was 4 elements, which is 2 times 2 order, we understand how to find. Multiply main diagonal, then secondary diagonal, and then subtract them, and that's it. Okay, but now how we find the determinant of 3 times 3 matrix? How you find its determinant? Okay, in this case now, first step to do it is repeat the first 2 columns. These 2 columns, repeat them here. 3, 1, 2, and repeat this one, 1, 0, 3. So this is now the first step. What I did, just I repeated the first 2 columns. Now make diagonals. You are ready now to make diagonals. Okay, this one you see, they make a diagonal, and the first diagonal will be inside the main matrix. Good. And the second diagonal here, good, and the third diagonal here. And each diagonal, as you see, it passes through 3 elements. Good. These ones now are green. We're gonna make them green, and these ones now main diagonals. And secondary diagonals, this is 1, as you see, it is inside, and this is 1, and this is 1. When you draw your diagonals, make sure what you get. You will get here, this element and this element are not used. Only. That means they are not inside the diagonals. Only these 2 other ones, all they are there. And in each diagonal, it crosses through 3 elements, and each element is from different column. I hope that is clear. Good. Okay, now find the result of each one. Multiply each diagonal numbers and put the result. Okay, here now, for the green now, for the first green here, as you see, 3 times 0 times 1 is going to be 0. Good. So this means it's what? 0 here. So 0 here. Okay, and the next one here, 1 times negative 1, negative 1, negative 1 times 2, will be -2. Okay, thank you. What else? Third one here, what I write, as you see, 3 times 1, 3 times 2 is 6. Good. And now add these ones. Add this green diagonals. 0 plus -2 plus what? Plus 6. As you see, it's going to be what? It's going to be 4. Good. I finished this one here and it is 4. Do the same way for the blue diagonals here. On this one, what will you find? 2 times 0 times 2. What you define? 0 times any 1 will be 0, so that means here will be 0. And here now 3 times 1 times 3 is going to be what? And here is 1 times 1 times 1, it's going to be 1. Now, what you do now? Add these blue ones. Add them, you'll get what? Now what you do here in this step, what you do now, which is the final step, main diagonals result minus secondary diagonal. So it's 4 times or minus 4. No, it's main diagonals, which are the green ones. So it is 4 minus, it equals what? Okay, in this case now, you find the determinant of a matrix that is 3 times 3. And I hope that is clear. Okay, we use determinants in many things. And you can do this question again, and you can do other questions to make sure. And also in the website, you have questions, you can do them. So we understand now how to find a matrix when it is 3 times 3 and how to do them. Okay, we have many applications for this one in real life, but one of the main applications is how to find, and that is here, that we study it as well here in this part, is how to find the area of a triangle that you have its vertices. Okay, we're going to take this example. This example here, look, we're going to draw a triangle. This is now a triangle that is from this point to this point. As you see here now, to find the area of this triangle, we know that we multiply base times height divide by 2. The base is 1, 2, 3, 4, 5, and here is what? 4. So 4 times 5 is 20. 20 divided by 2, so that means the area here is 10. The area here is what? Is 10. Good, the area is 10 now. If the area is 10, and we understand that base times height divided by 2. Can you use determinants to find it it's 10? Yes, and we're going to take this example to find it. Okay, if we take now also another example, another what? A triangle. We'll take another triangle, which is this triangle. You see it? This triangle here. And here, these 2 points, and this point here, you see? This triangle. Is it easy now to find the area of this triangle? Is it easy? This small triangle, is it easy to find? You don't know the base and the height because you didn't have 90 degrees maybe in it, right? So it's hard when you don't have 90 degrees on that one. It's gonna be what? Harder to find the area. We take here another, just to draw you another example, how if I have this triangle here, and this triangle here, and this triangle here. You see these 3 points, when they make this triangle, is it easy to find its area? Okay, you didn't know how long its base, and you didn't know how long its height, you didn't have 90 degrees, because the area, to find the area of a triangle, base and height, they have to have 90 degrees between them. So now you multiply base times height, divide by 2, and you can find it. Okay, now we're going to understand how can we find this area by determinants. And same thing, we're going to practice this one, and you'll find its area. Okay, to find the area of a triangle where you have its vertices, first write its what? Its vertices. So that means, as you see, this one is 1 and 1 as a point. And this point is 6 on x and 1 on y. Good. And this point, as you see, it is 6 on x and 5 on y. Okay, now, to find the area, go to draw a determinant. And in this determinant, write the first point. No problem what is the order. Okay, right here 6 and 5. And I write here 1 and 1. And I write here 6 and 1. Okay, as we know, determinants have to be squares. Determinants have to be squares. Is this one now square? No. So that means we have to make it square, so you add numbers here, 1, 1, 1. Now, to find the determinant, what do? First, we said we repeat the first two columns. So these two columns, we're going to repeat them here. 6, 1, 6 here, and 5, 1, 1 here is repeated. Now, just we make the diagonals. Here, we write the diagonals. Diagonal number 1 here, and diagonal number 2, and diagonal number what? 3. We multiply them now. 6 times 1 times 1 is 6 here, and 5 times 1 times 6 is 30 here, and 1 times 1 times 1 is 1 here. Good. The other one here, I'm going to use yellow color. Here, when you multiply 1 times 1 times 6, it's going to be 6. And here, 6 times 1 times 1 is going to be 6 as well. And here, you multiply 5 times 1 times 1 will be what? 5. Now, add these ones here. 6 plus 30 plus 1. If you add these ones now, it will give you what? 37. Good. And if you add these ones now, as you see, 6 plus 6 plus 5, it will give you what? 17. Now, subtract them. 37 minus 17. 37 minus 17, you'll get what? 20. So this is now the determinant of the vertices. Okay, half the determinant will be what? Will be the area. Half of the 20 is what? 10. And as you see here, it is what? It is 10. So he found now the area of a triangle by putting its vertices in a determinant, and he completed the third column by putting 1, 1, 1. Then he found its determinant by repeating the first two columns, and he found the diagonals, the main diagonals and secondary diagonals. Then he multiplied them, then he subtracted. Then in the end, I find half of this one here. So we found it here, what? 10. Okay, I advise you now to repeat this one again. As you see, this is a triangle. Its vertices 1, 1, 6, and 1, and 6 and 5. These ones, the vertices. Make your own matrix. Then find its determinants. Same thing we do. And make sure you find it in the result, in the final 20. And half of it will be the area of this triangle, which is 10. And also now we'll find the area of this second here triangle, same way. And you can find it by yourself before we do it together. So for the second now triangle, what are the vertices of the second triangle? I put them on what? On the diagram. So now we're going to find the area of this small triangle by using what? Vertices. First step, we write its vertices. As you see, this one here, it is 2 on X and 4 on Y. Good. And this one here, it is 1 on X and 6 on Y. Good. And this one here, it is 4 on X and 7 on Y. Good. I write these numbers now as a matrix. So I write this matrix here, 1, 6 here. Good. And 2 and 4. Good. And 4 and 7. Now, what should I do? We said we add here 1, 1, 1 to make it what? To make it a square matrix, right? Then we find its determinant now. So we repeat the first two columns. These two columns, we're going to repeat them here. 1, 2, 4. And here repeat 6 here, 4, 7. Now we make the diagonals. So this diagonal now, this is the first diagonal. 1 times 4 times 1 is 4. This is the second diagonal, which is 6 times 1 is 6, times 4 is 24. And here now 1 times 2 times 7 will be what? For this diagonal, it's going to be what? 14. Okay, now I'm going to use pink for the other side. So now we're going to multiply here 1 times 4 times 4 will be 16. And here 1 times 7 will be 7. And here 6 times 2 times 1, it's going to be 12. Now I add these ones together and I add these ones together and I subtract. So here, as you see, 14 plus, here it's going to be 38 plus 2, it's going to be 42. And here, and you add, here it's going to be 12 plus 7, it's going to be what? 19, add 1, it's going to be 20, so that means it's going to be what? 35. Now subtract 42 minus 35. It equals what? It equals what? 7. So this is 7 is the determinant. The determinant, half of of this determinant, which is 3.5, is the area of this triangle, 3.5. So the area that has vertices 1 and 6, 4 and 7, 2 and 4 is 3.5. So this is how to find the area of a triangle that you know its vertices by using determinant, as is one or an application of finding or applying determinants. Thank you so much for that. See you in other videos. Goodbye.